This video has been made to go along with the Java variables and data types lesson. So first thing we'll need to do is start up a new Java project and add our basic class. We'll give the class the exact same name as our project, and we will click on the default constructor for the main entry point and hit finish. And we're right into our class. So first thing that we need to look at is some of the basic data types in Java. Java, the primary ones that we're going to look at are the integer, or int, which are your basic 1, 2, 3, 4, doubles, which are our floating point operators, booleans, which are trues and falses, and strings, which, while are not technically a primitive data type, they are very useful. Strings are actually made up of an array of characters. So the first thing that we are going to look at, though, is how to declare them. We can declare them just as integer x or integer y, and then we can assign a value for them, like x equals 3 and y equals 4. Or we could actually assign a value as we create the variable, such as if I say tax rate is 0.12, or I could say double interest rate of 0.5. So I can assign them values while I construct them. Similarly, a string, hello world in this case, can be our basic one. Booleans, once again, it can be true or false. So I could say that you are passing this course, or I could say maybe you're not passing. But we're going to hope that everyone's going to pass the course, so we'll set our passing to true. Now, another declaration we can use on our variables is the final keyword. And this is when we are creating variables which have an absolutely fixed value which will never change again. So we could say, for example, pi is 3.14. If we are initializing the screen height and width for, say, a graphics area, we would assign that as a final. When we do assign finals, we also put them in all capitals. It's just a convention that people start using. So now I want to show you a little bit about the math behind variables. I'll set a couple such as x is 2 and y is 5, and then I'm going to say that the result of 2 divided by 5 is also an integer. Now what is this? If you try the math in your head, think about what you think that result should be. But if I sit there and I tell the system to print out the result and I run it, we actually find out, if you look at the bottom, we get 0. Why do we get 0? Why don't we get 0.4 like math would tell us? Well, problem is here with integers, it always rounds it off. So if I do 999 divided by 1,000, you might think you want 0.999, but once again, because it truncates, it doesn't even round it, sorry, it truncates it, it takes it right down to 0. Now, I'm going to change the value to double. So now I've actually got decimals here, 999.0. And I'm actually going to take the result and divide a double by an int. We now get 999. Now this is a neat thing about Java, is that Java is somewhat smart. It is going to try to convert that y, that integer y, into a double for us. Here's the other thing. If I try and say integer x is 1.1, it's not going to like that. In fact, Eclipse gives me the little error and tells me this is not an integer. So I'll correct it to a double and tell it 1.1. But how about this? What if I try and do double y equals 1 divided by 3? What do you think y will print out? In this case, actually, we once again get 0.0. This is because 1 and 3 are both integers in this case. So it does the integer division first of 1 divided by 3 and truncates it. Then it does the smart convert to double. So this was our problem here. It is kind of strange to think, but Java does try and perform a sort of order of operations, and in this case it will perform the math on the data types it currently has first before trying to convert them into a second data type. As I said, in this case, it does integer math first, and then it's going to convert it and pass it to double. Another feature that Java has built in is an attempt to convert data types. We call this casting. And in order to convert a data type, we can actually apply the data type in parentheses, such as here where I'm going integer in parentheses math.pi. Now math.pi is a specially built-in value of 3.141 and so on. But the integer in parentheses will actually truncate that 3.14 to the 3, as you can see down below. Similarly with its order of operations, here I'm trying to multiply it by a double of 20.0, but this is giving me an error. You can see the little X mark over in the left. This is because int math pi converts the pi value to an integer first before attempting to multiply it by the double. However, if we put parentheses around the math.pi, so pi times 20.0, it'll convert that to the double first, and then it'll do the mathematics of multiplying the double first, and then it will cast it to the integer. So it'll do 3.14 times 20.0 and gives us 62. However, so if I do a math.pi times 20, an integer value of 20, what do you think this will give? In this case I run it and I get 60, not 62. This is because it converts math.pi, the 3.14, it truncates it down to 3 when it converts to an integer, and then multiplies 3 times 20. By now I hope you can all do that math in your head. Now I'm going to show you another neat trick about how integers and strings can work. So I'm going to create two variables here, an integer of x of 5 and a string called greeting, just saying hello world. I'm now actually going to do a mathematical operator of greeting plus x and print out the result. What do you think that result should be? Now we know we can't do words plus numbers, so it actually does something called concatenation. This integer 5 actually is just stuck onto the end of our string. I'll put another integer in there, 4, and now I'll do greeting plus x plus y, and strangely enough, because we are converting it to a string, it just adds them all together, and it's hello world 5, 4. It's treating both the x and the y as a character value. Now what I'm going to do is I'm going to remove that. I'm just going to put x plus y in the print line. What will this do? In this case it's printing 9 because it will actually do the order of operation x plus y first before actually converting it for printing out in a string. Now the other neat thing is that Java has some built-in math types. In its math library it has the ability to access pi, for example. It is stored in there. We have the other abilities such as an absolute value function. So I can say, what is the mathematical operator absolute value on negative 4.4? If I run it, we get 4.4. That's not surprising for those of us who have done absolute values before. We also have the ability to do square root. So I can pick any number, square root of 81 for example. I can pick random numbers. This is very useful in all sorts of applications. The random number generator actually only generates from 0.0 to 0.999. So if we want to get a value greater than 1, we actually multiply it by the maximum value. So I could say math random times 5, and that will give me a value of 0 to 4.999. You notice we don't get 5 here. There's also a nice built-in exponent function or a power function. So it's done as pow 2 comma 3. This would do 2 to the power of 3. So the first number is your base and the second number is your exponent. They've got a pretty large memory storage here, so you could bring that number up pretty high. I have not tested it to see what the maximum number is. So back to the random. So if I want to actually get a random number, so random times 5, so if I actually want an absolute solid value, I need to cast it as an integer type, because the math random does give a double value, a decimal value. So in this case, I will say math.random times 5. This will give me from 0 to 4.999. We're going to add 1 to it, so it gets from 1 to 5.999. And then, similar to before, that integer casting in the parentheses. We'll just truncate that, so now I get a number from 1 to 5. So you can use this random number feature to get your 6-sided die for that assignment.